All right, welcome back to the Sundry episode of this Introduction to Coding. This will be the final teaching, in big quotation marks, episode of this series. The last episode, I'm going to probably live stream over at my Twitch channel, which is King OTMFU, K-I-N, this one, that one. So I'll add a link down below, and I'll make sure to put a video out saying when I'm going to do it and stuff. It'll probably be next weekend, hopefully, but we'll see how I go with time. The second thing, I've changed my keyboard because this HyperX one was kind of felt weird, probably because I put the silencers on it. But I've got a blue keycap keyboard. I don't know if it's cherry or not. Doesn't look like it, but it's a very nice keyboard I bought from a local budget internet brand called Kogan. It cost me like $20 and it's pretty fucking solid, so I'm happy with that. RGB as well, but it is a little bit louder, and I apologize. I did do a test recording and it sounded okay, but I don't know how that's going to come through to you, so hopefully it's not too bad. But then again, hopefully I'm not going to do a lot of typing in this. It's going to be more of an explanation. And yeah, I've already got some code here, and I'm just going to quickly go through it now. So this is the main. And we've got two classes, book and page. You could probably guess. Let me just do that, actually. That is unnecessary. So the book class, I've got it in header and source files as of the last episode as well. There is no inheritance at the moment because it's not necessary. And the things we're going to be talking about doesn't require inheritance at all. So it's got a constructor that takes a number of pages. You can add a page, you can get the current page count, you can get a page, or you can get the entire book formatted. Its variables are a number of pages, the current number of pages, and a dynamic array of pointers to pages, which I really hope I went through dynamic arrays. Fuck, I don't actually remember if I did. Quickly have a quick squiz. Yes, I did. Sweet. Cool. That saves me doing that in this episode. And then just the implementation is pretty simple. When I create the object, I create the array. I assign the number of pages to the number of pages we've got, and I set the current to 0. When I add a page, I make sure that we haven't run off the edge, and we increase the number of pages as well after we assign it. The get is a get. Getting a page, make sure you're within a space that we know of, otherwise return null. And getting the entire book just returns this formatted thing, and I'm going to go through this as part of this. The page class, this has a constructor that's empty, a add text function and a get text function, and then a page text. So I've done this kind of, I'll just do a quick clear function as well. Oops. And oops, again. Oh, good Lord, what is happening with my brain right now? Cool. So it's extremely simple class. And in main, I've created a 100-page book. I've created a 100-page that says text, which, why the fuck not? And then I'm outputting my entire book after that. Who is emailing me? My security cameras, okay. So the output is just this. So what are we going to talk about today then, after we have all this stuff? What are we going to talk about? We're going to talk about operators, and specifically how to create your own. And of course what they are. I think I've explained a little bit, but I'll go into a bit more depth. Escaped characters, which is this guy here. Destructors, which I think I might have touched on a little bit in this one. No, I didn't. That's fine. That's perfect. Source control. Now, I actually forgotten to sort of do what I wanted to do with this, but we'll talk about source control a little bit, what it does, how to use it, and sort of go from there. All right, sorry about that. I just went and created a repository So we can talk about source control a little bit further on. We'll talk about namespaces, which I have talked about before, but I want to talk about some of the ways you can avoid doing standard string like this every time, and like the best way to use namespaces. Recursion. I want to talk about recursion and why that's somewhat important, just to at least get your head around. We'll talk about the debugger in Visual Studio and how that is extremely useful. And I have function overloading here, which I have talked about a little bit. So I might not go into that. Just double check. Yeah, I think I have gone into function overloading. Where would functions be? If I was more organized, this would be less of an issue. This is too far back. Okay, maybe we haven't done function overloading, so we'll talk about function overloading a little bit as well. So let's jump in with probably the easiest one to talk about. That's escape characters, which I'm going to go bring up the entire list of C++ escape characters, and I'll explain what they are while they're on the screen. All right, so let's talk about them. The main reason for this is there are some characters that you want to put on the screen which aren't characters you can actually type with a keyboard. Things like the new line character or the enter key. How do you type the enter key? Other ones are things like the single quote and the double quote, which this is a really weird set of sequences. Like half of these ones I don't think I'd ever use. Doesn't matter. Like the single and double quote, which are like this one here. If I wanted to have a double quote on screen, I wouldn't be able to do that with an escape character. So basically what an escape character is, it just allows the C++ interpreter or language interpreter or whatever to actually know that the next character is a specific character. It might not be represented by what it is, but it'll be able to go and convert that back to whatever else. So in the case of this guy here, /n, that is the same as doing this. Hey. Oi. Oh, I'm just gonna crack the shits because it's a character. So you can see that's there. But it hates it because I'm using string concatenation, so we'll just get rid of it. It's the same thing. And this is cool because then you can go end of page, start of text, and you don't have to create 3 different strings using standard end in the middle. That's a pain in the ass. Stop doing that. So some of the other common ones are / talking mark, quotation mark, whatever you want to call it, which allows you to do a talking mark on screen. /R. So /R is, I believe, the Mac new line character, and Windows uses /R/n. If you have Notepad++ and you go turn on characters, where the hell is that? This guy here, the P looking thing. You actually see CRLF. So CR is carriage return, which if you go here, doesn't actually, yeah, okay. R is carriage return, and then LF, which is line feed, which is N. It's taken from a typewriter. Windows is very literal. Linux just uses /n, and I believe Mac uses /r. There is, in the edit menu, end of line conversion to the old Mac is just carriage return. So new Mac is Linux, so it's not really a big deal. That's what that does. Other things like /t, which is your tab, I believe. Yep, horizontal tab, and V is a vertical tab. So stuff like that. You can do, especially when using consoles, you can do some pretty funky shit that you wouldn't be able to do otherwise. So that's just a really simple thing. Keep it in your mind. You'll see /n a lot. I use /n a ton. Not so much /r/n because I'm lazy, and most programs interpret /n as a new line anyway, so you don't need to have both. But some, like if you're doing output to text files, /r/n is generally the way you do it, especially for a Windows file, because Notepad fucking hates it if you don't have the /r/n, and it just doesn't work. Operators. So let's talk about operators. Now, operators, we have spoken about a little bit, and I'm going to apologize for my hair, I'm a bit messy. Operators are special types of functions represented by characters. So this here is a prefix increment operator. It's at the start, so it's prefix. It increments because it goes up. Other operators are stuff like this. The less than operator, which is a comparison operator. The equals, which is the assignment operator. This guy here is another comparison. Equals equals is a comparison. You have and, which is your logical operator, sorry. And all those things you can actually overload. And it's not overload, you can overwrite or create your own. So in the case of this, I actually wanted to do a couple of specific ones. Now, I'll just come up and say it. I have not written a operator in probably about 8 years. So I've got the syntax up next to me here, so you'll probably see me glancing over. And I apologize for it, but you just need to bear with me while I bring up the correct one. I'm entirely too upset by operators. I can never get these fucking things right. I know how they work. I know how to write them. But fuck, I can never get the syntax correct because of reference versus value versus pointer versus const stuff and all this bullshit and the exact syntax. It always fucking kills me. So, I'm not going to go too far into it. This is it. Operators exist. You can make your own. Moving the fuck on because I'm getting very upset. Destructors. Let's talk about destructors, because destructors I can tell you about, which I think I've gone into a little bit as well. But a destructor is what is called when an object is deleted, the opposite of the constructor, obviously. And when you're using pointers is when you want to be cleaning up that memory. So in the case of a book, like a page, all we've got is a single string that is not a pointer. So when that falls off the stack, when that gets deleted, that'll just remove all its own stuff. That's fine. But we're using pointers here, and we could have a lot of data floating around. So let's, and I've gone through this a little bit with the pointers before, so we can have a look at the memory management and actually see how much memory we're using. When it comes up over here, come on. So we're using about a meg. We gotta up our game a little bit, I think. Let's say int number of pages is equal to 10,000. Oops, that's not quite what I wanted. How much RAM are we using now? 3 megs. Okay, cool. 3 meg is good. So now let's delete this book. Delete my book. And what you're going to see is, hopefully, program is making me look stupid today. Yes, we're still using 3 meg because even though we've deleted it, we haven't actually gone in underlying and deleting the data. So what's happened is these two have gone, and the pointer to the array of pointers is gone, but the data still exists. So we actually have to tell it to go through and delete all this stuff. So what we can do is we can create a destructor, which a destructor has the same syntax as a constructor, nearly. So it doesn't need a return type, but it has the tilde. I think that's the tilde. Ooh, yep, cool. Then the name and no arguments. There will never be arguments. And what we need to do is just say delete, I think that's C++ pages. Oh, okay. So now if we run it, nope. Oh, okay. Let's do it like this then. I delete pages. All right, let's try that one. All right, So it's spiked, it's got deleted, and they've been removed. So what I'm doing here is going through and actually deleting every page and then deleting the array of pointers. This one is necessary because the pointers will hang otherwise. They'll just be empty pointers, and that's bad. So that's good. That's down to 1 meg, which is what we expected, which is what it was, which is basically what it is when you're not doing anything. You use about 1 meg of data to just keep the application running. So awesome. That is Destructors. It's a very simple one. There's a couple of objects in my game that have like hundreds of pointers, and you have to make sure you delete them all. Yeah, that's cool. So, namespaces. Now, we've dived into namespaces before and how to write them and all that kind of funky stuff. But let's talk about how we get rid of this. There's a few ways. And I really hope I've talked about how you divide stuff into namespaces. I'm going to assume I didn't. We're going to put our book into a namespace called library. To do that, you just go namespace, library, and then cut and paste. Now, in here, this is all going to whinge because it doesn't know what book is. There's 2 ways we can fix this. We can add our library namespace like this, but that's a pain in the taint. Is it going to make me have to be a liar? No. Okay, good. So we can just do the same enclosing namespace thing here. It doesn't really create, that doesn't require anything like specific. Everyone can use a namespace. It doesn't really matter. It is what it is. And then we're going to go into main. It's going to say, what the fuck is a book? Now, there are 2 ways we can do this again. So we can go library, book is a new library book. Or, what we can do is, we can use what's called using. Now, using allows it to say, everything in this namespace is what will be the default. So when there's no namespace defined, that is what we will use. But there's 2 ways you can use it. You can use a whole namespace, or you can use something very specific. I would not recommend using a whole namespace. I'll show you how to do it because it's probably used everywhere in whatever code you might look at, but I wouldn't recommend it, and I'll tell you why in a second. So we can go using library. I'm so sorry. My brain literally broke for a second there, and I had a fit. Yes, sorry, using namespace library. That uses the entire namespace. The other way you can do it, and you can see the red lines went away. The other way you can do it is you can go using something very specific. So using library book. And that will also work. It won't bring in everything else with the library namespace. So if I have like page in here. And you're going to work in a second. Are you fucking serious? Have I typed the namespace wrong? Yes. Oh, Jason, what is happening to your brain today? Alright, much better. Fucking Jesus. But now this is having a whinge because we're not actually specifically using that. If we were to do using namespace library instead, that would fix that. Once again, I do not recommend this. And the reason being is if you are using a namespace and say standard is obviously a big one. This is what you'll see in a lot of code. So you don't need to have standard cout, it's just cout and cin. And you don't need to have standard string, it's just string. But there's a lot of stuff in standard. There's a fuck ton of stuff in standard. And you might want to create something of your own. And it's not going to work because you're using that entire namespace. So if there's something that you've created with the same name as something in the std namespace, it's going to take that instead. So I would recommend using very specific snippets. In the case of library, because it's all my code, it's a bit different. I still wouldn't recommend it, but you can. I would recommend using standard cout like this and cin. It's a much safer way. It's much more verbose. It's a lot more stuff to type, a lot harder to maintain. But when shit goes wrong, and it has only once for me in 15 years, it's gone wrong once. and it took me like a whole day to debug it. And I said no. From then on, never again will I use a full namespace like that. But you can. So those are your two options. So we did speak, I think, a little bit about function overloading, but we're going to do it again. Now, function overloading is the ability to assign more than one set of data to a function. So I don't really have a good example here, unfortunately. So I might have to, let's use the clear function. Let's say I've got a clear function, but I also want to be able to specifically clear one part of the page. So but I want to go like clear specific. That's dirty, you know, and take like a start and an end character, position, whatever. That's a bit dirty. What I can actually do is, because the signature is different, and when I say signature, the signature in this case is the name plus the types. So the signature for this, in this particular case, is clear int. You can't have something like this, so void clear int, then A and B. Well, they're named differently, but yeah, but the compiler doesn't know which one you want. It has to be unambiguous. Although it's saying that's fine. That shouldn't be fine. Let's create an implementation for it. See, it's actually created it for both of them. It's going to be very confused. It might actually not compile. It shouldn't compile, yeah. It's already defined or declared. So you can see it there. The signature is int. It doesn't have the name. And also the return type, you can't just go int clear. Int. That is also not correct, because cannot overload functions distinct by return type alone, because it doesn't know what you want. It's still ambiguous. Computers need to be told exactly what you want it to do. And in this case, we can tell it. We can either clear with no arguments and clear the whole thing, or we can go page text. Now, usually I do some kind of sure, you know what? Let's just do it like that. I do some actual validation and do it properly, but we're just getting the substring and whatever. It doesn't really matter if it works or not at this point. I'm just sort of showing off the concept, because there's not really, I don't really have a good example here. A proper example might be something like, you know, if you have an inventory system in a game, you could have add and then like gold, or add and then an item, and add and then a weapon. Something like that. And then it's just the one function call, and you can throw whatever you want at it, and it all makes sense instead of having add item, add weapon, add gold. Just add. It knows what you want, just add. Very simple, but it is something you see quite a lot. So I still haven't talked about source control, which I want to do last, and recursion and the debugger. So let's talk about recursion. So recursion, apologies for that. So if you actually go and search for recursion, Google has a bit of a thing. Did you mean recursion? Did you mean recursion? Recursion is when something is calling itself. Now, why would you want to do that? There's a couple of pretty easy examples, and I'm going to do the very simple one. I'm going to be doing a multiplication. It's going to take multiplication, no, we'll do power. And when I say power, I mean like 4 to the power of 2, 4 to the power of 6, whatever. So we'll take the, I don't remember what the technical term is, we'll just call it number and int power. Okay, extremely simple. And the way we're going to do it is, and if you've never done this kind of like math and broken it down before, it might be a little bit confusing, and I apologize for that. But when you do a power, it's just, so 4 to the power of 2 is just 4 times 4. 4 to the power of 3 is 4 times 4 times 4. Or it's 4 times 4 to the power of 2. So you can break it down like that, and then hopefully you can see that. So 4 to the power of 6 will be 4 times 4 to the power of 5. Oh, nice job. which will be the same as 4 times 4 times 4 to the power of 4, etc., etc., etc. So we can exploit this to use a recursive algorithm to work it out. So what we're going to do is, if power is equal to 1, that's assignment. Power is equal to 1, we're going to return number. If we don't need an else because we're returning, so it's implied. If power is equal to 0, return 1. Anything to the power of 0 is 1. I don't actually remember. 4 to the power. Maybe get out the fucking scientific calculator. 4 to the power of 0 is 1. Okay, cool. Otherwise, what we're going to return is is number times power, number, power minus 1. Wow, that's confusing. We'll just call this P. How about that, to get a little bit less confusing? So what we're going to do is, if the P is 1, anything to the power of 1 is itself. So just return itself. If it's 0, return 1. Otherwise, we're going to go our number times the next power down. And so, let's just do that. We can go int cout power of 2 and 8. And this should give us, what is it, 128? You think for a program I've done my 2 power tables better. 256, god damn it. But that's what we expected. And this brings us into the next thing, which I can sort of go through, is the debugger. So we can use the debugger to sort of see how this works. Now, the debugger is your most powerful tool. There are a lot of people who hate this because it's not pure. They're the kind of people who use Notepad to code. I fucking hate those people because they're stupid. They are stupid because they refuse to use the most powerful programming tools ever created just so they can be pure. Fuck you. That's it. Sorry. But the debugger allows you to do a lot of really cool shit. You can check memory while it's running. You can pause the application. You can sort of see the code as it goes by. It can give you things like exceptions, and when things crash, it can tell you why. Stuff like that. But let's go to the most simple thing, a breakpoint. What a breakpoint is, it's this little red dot here. If you're on Visual Studio, if you click down this left thing, you'll get a red dot. That's creating a breakpoint. When the code is about to execute this line, it will stop. So let's do it. Let's start it up. Look, it stopped. We can go and check every piece of memory that we have access to at the moment. So for instance, number of pages is 10,000. My book is deleted, so that doesn't help. But I'll show you something else that the debugger can do in a second. But then we can go, all right, I want to see how this power function works. We can actually jump in and follow the execution down step by step. So up here are your step into and step over commands. So step into will go one step in. So in this case, it'll open up our power function. Step over will go one step down, so it'll go down to this guy down here. And step out is up. So we're going to step in, so that's F11. I always forget when I'm talking, F11. So look, now we're up in the power function. We can actually see how this program is operating, see what happens in the background, and that's cool. So we can see what our number is, 2. Now this yellow thing here you won't have. This is called intraline inline watch, Etrian inline watch. It's not free. It's like $15 for a lifetime license. If you're a coder, if you're going to do it professionally, I'd recommend it. It's kind of cool. Otherwise, you have this window down here called autos. If you don't have it, you can go to view other windows. It's somewhere. Is it under debug? Debug windows. Yeah, here we go. Autos. And that will bring up all the relevant, or all the things that Visual Studio deem relevant to what you're currently doing down there and show you the values. and they will update as you go along as well. This is really handy when you've got a really big class. You can also dive in. If this was a class, you could actually go and expand it out and go and look what's inside the book or inside the page and actually see all the stuff in that as well. There's also some other shit you can do. You can see all the breakpoints, which I've only got one. You can see the call stack, which is how the program is actually drilled down to where you are at the moment. So these two guys here are the windows starting up the program. This is my main function, and you can step back into it and see where it's come from, and then where we currently are. You also have immediate window, which I'm not sure how good it works in C++, but in C# you can actually type code here relevant to the data you currently have, or in relation to the data you currently have. So you can actually go and say number plus p. Oh, it actually works, it's 10. This is extremely handy when you're debugging if you don't want to put in debug code everywhere, or if it's crashed and you've sort of caught it and you haven't got the debug code there. You can do it on the fly. And I would have killed for this 10 years ago. Output shows debug window output. That's not as useful if you're doing a console application because you can just put it on the console. Error lists is mostly for coding. Locals is kind of like autos, except it's only local stuff. So that's kind of useful. And watch. Watch is you putting in your own autos, locals, like watching things. So in the case of this, it's not really useful because I've just got two numbers. But maybe you wanted to watch the number of current pages change in the book, and you could put it in here. And I'll do that for you till after this and show you how that works. So we're going to step down F10. So is p equal to 1? No. Is p equal to 8? No. So this is going to go number times power like this. And let's step into that and see how it goes. So now you see p is 7. It's going to do it again. Now you see p is 6, p is 5, p is 4, p is 3, p is 2, p is 2. I went one step too far. Crap. All right, I went a little bit too far. I skipped one. But you'll see this. Power returned 8. So 2 to the power of 3 has returned 8. My cameras again. Nope. Someone keeps trying to hack my accounts. It's like we're in one of those like hacks where they dump your emails. So everyone goes into your emails and tries to just try random passwords. Doesn't matter. So we can actually see that this function returned 8. And if we go further, we can see that function returned 16. So that was 2 to the power of 4, which I think is correct. My brain is so fucking fried. Yes. Good Lord. Good Lord, Jason. And then we can go, all right, so the next one. It's returned 32. It's returned 64. It's returned 128. And then it's returned 256 to this one here. And we can actually see that happening in real time. It's really great when you were trying to debug like a big if statement. So like if this equal to this, this equals this, this equal to this not equal to this less than this. It will actually show you all the return values of those, true, true, false, true, to see which ones are failing. Or if you're doing something more complex, it's very useful. But let me show you something even cooler. You can time travel using Visual Studio. Doc Brown would be so proud. This yellow arrow that shows you where you currently are, you can change that. Now I'm back up here at the start. This is really good if you want to rerun an operation, or to say you have an if statement and you want to see what happens when the if is the other way around. You can drag it into that if statement and show it happening. You don't just have to go forward, you can go back. You can go forward. Like this. So we can actually go and see. So it's created my book. And if we go to locals here, you'll see we have my book, and we can expand that. Number of pages is 10,000, current number of pages is 0, and the pages, and we can expand the pages, is an array of pointers. Now, unfortunately with the array of pointers, it doesn't always do quite well, but let me show you what you can do. So let's put a breakpoint down here so I don't have to go through this 10,000 times. Let's skip down to there. Current number of pages is now 10,000, but you can see here there's only one page because of the way arrays of pointers works, and Visual Studio doesn't like it too much. But what we can do is we can go my book, that thing, pages 500. And it will actually show you the 500th page. Same thing as if we go 10,001, it's null because that doesn't actually exist. Now in the real world that wouldn't be null, that'd be like bong memory and would actually crash. but because this is in debug mode, it sort of gives you a little bit more leeway. And that's the kind of really cool shit you can do. So if we go back up to here and change this to, say, page 1. Do we do that? Then we go through and we create a new thing. Now, if you, I'm pointing at the screen. It's gone red to indicate between the last breakpoint and this breakpoint that we're at now, it's changed. And it's currently CD, which is Visual Studio talk for bad memory or undefined memory. Then we'll go through, create the first page, it's still undefined. Create the second page and add it. And now it's defined. We know what memory address it's at and we know the page text. And we can expand it all. We can see all the bullshit that the string uses to make it work, and etc, etc, etc. The debugger is so insanely powerful. You can do other cool stuff with these breakpoints. You can do conditions. So when I is equal to 100, I want it to break. Look at that. I is 100, it is now broken. And I can go through and see what the 100th page does. I can change this to a condition. An action. And I can log something to the output window instead. So I can go... I think this is the syntax. So I'll get rid of that. I mean, that probably wasn't an issue. So we can go I... And yeah, that'll do, whatever. Cool, and if we look at our debug window, when we hit this breakpoint, it's outputted I. I'm pointing at the screen again down here. It says 101, and then 102. But we don't actually have to step through it, we can just go like this. Actually, make me out to be a liar, but no, it's very slowly printing out all 10,000. Printing out to a debug console is painfully slow, and I would recommend not doing it unless you absolutely have to. In that entire time, it did 190. That's why when you run things with a console window, things tend to run slower, especially if you have a lot of debugging. That's why most applications run out of debug console, unless it's 100% necessary. But that's the debugger. How fucking cool is the debugger? In the next episode, you're going to see me using the debugger because I'm going to fuck shit up, and that's definitely going to fix it. So, let's talk about the last thing. So, let's just exit that. Well, exception, we don't care. Source control. Now, the beauty of this day and age, the internet ages, you can do so much for free. You can go, if you want to create a public project with you and your friends and you want to have everyone be able to access it, you can go to GitHub and create a public project for free. Unfortunately, I don't like putting my code out there for the most part. So I wanted to create a private repository and I couldn't do it without GitHub charging me $6 a month, which is reasonable. You remember, it's backed up, it's on the internet, it's available everywhere, and it's probably going to be really quick. But I don't like spending money. Then Microsoft comes along and says, hey, we have our Azure DevOps suite, which is code repository, reviews, testing pipelines, build pipelines, Scrum boards, all this kind of stuff. And it's free if you have less than 5 people on your team. Fuck, sign me up. And you can do private repositories. So I actually have one of these for work. Our work users one, I should say more specifically. I have one for my private project. I used to have it self-hosted. But that was hard to manage, and I was really scared that my house was going to burn down and I'd lose everything, and now it's on the cloud, so it's magic. And then I have one for this, which I'm probably going to end up deleting straight after this because it's pretty trash. But I can show you how to use it. Once you've actually gone through and created it, I probably should have just created it on screen. But once you've created it, we are going to... Okay. We're going to add the current code to source control, and as I do that, I'm going to explain what it actually means. So this adds the source control button here. Visual Studio has done so much good work. Apologies, I'll make a note to blur out my email and just to log in and stuff. So I've got this repository that I've created called Intro to Coding, and I'm just going to publish it. So what I'm doing here is I'm actually taking all of this code that I've wrote, everything in this project, and sticking it on the internet. Now, it's in a public repository at the moment, but you can create a private one, as I said, for free, so that's fine. Oh, my internet is just going like absolute trash today. You can see it just sort of going very slowly. All right. It has pushed. And now we go over here and refresh. And hopefully... Nope. We're on master and we pushed. What is happening? I've created a new repository. That's what I've done. So I can go to my new repository. So I'm on the right repository now, and you can see all this stuff is now on the internet. So you're thinking, okay, great. I can copy files onto the internet. I can zip it up and send it to myself in an email. Why would I bother? Okay. Let me show you why. I am going to pretend I'm not me being awesome, and I'm some other douchebag being a douchebag. And I'm just going to go do. And then I'm going to give it to you. Or I'm going to save it to the server, or I'm going to send it out in the zip. And you're going to be like, why the fuck isn't this code working? It was working yesterday. I haven't touched anything. But now I'm going to make sure I did a change. And I'm going to put it on the internet so that when you go to pull this down, this is what you will see. And you'll see, it's actually going to say down the right-hand side here, I did a change in here, on this file here. What does that mean? You did a comment, great. But look at this. You can go to the history. And you can go, ooh, there's a change here. What was the change? I clicked the wrong one, I did. And it goes, someone has removed this line here. That's why it's not fucking working. Now, in this very specific circumstance, this is very simple. This is one person, it's a really easy bit of code. But if I've spent 2 weeks working on something, and all of a sudden something stops working, you might have to go through a single file and say, look, this part here doesn't work because of this, and then fix that. And in the case of that, that's absolutely incredible. And on top of that is, just say I put something in here and I just fuck everything. Everything is fucked. I can then go, this last commit, which is what this is called, roll it all back, remove it all, and go back to one previous one where it worked. And you could do that. Or you as an end consumer or end user might we want to like, oh my God, my voice, might want to be like, I want to see what was the performance 10 versions ago. You can actually go down, and I think I can show you that from here. I will admit I don't know exactly how this works. Changes. No. Builds tags. Yep. I usually use a different application to manage the history part of it because I don't like the way Visual Studio's one works too much. But for view history, oh, here we go, view history. And you can go here and go, create a tag. I'm going to call this tag the, whoops, did it in the wrong place. Here I want to do it. This is the original commit. No spaces, Jason, no spaces. And then I can go to tags, and I can go here and go, check this out. And it's going to pull everything back, as you can see that the line has come back, to the way it was at that point in time. There are easier ways to do it. I did it the hard way. I don't know how to do it the easy way in Visual Studio. You could probably just right click and go check out, to be honest. No. Whatever. And you could do stuff like branches. What are branches? Well, let's just say there's 5 of us. And this is exactly how my office is. There are 5 people in my office working like this. We have our master branch. This is where everything after it's been reviewed by everyone else goes. And that is what we use to make our software builds. We can go, all right, I'm going to branch off master now. and I spend 2 weeks doing my work over here in my own repository. Then another guy might go, I'm branching at the same time, but it's only going to take me a day, and I'm going to put it back eventually. Because I've branched off, I'm now over there, I don't get that change yet, which is an advantage, because maybe they've changed the way something works, or maybe they've edited the same file I have, and they've just screwed everything. So then I go off my merry way, and I put my review in, and I finish my branch. That then collapses back in onto the main branch and merges itself back in. About 90% of the time, this will just be automatic, because there'll be hopefully no conflicts. Because usually you try to go, you work in this section, you work in another section. Sometimes it's not possible. Sometimes there's overlap. Sometimes you have to manually resolve these merges, but that's fine. You go, oh yeah, this is old code, this is new code, this is also new code, so just shove it together, kind of thing. It can get very complicated very quickly, but it can also not. And that allows multiple people to be working on the code at once without impeding other people around them. And it's an extremely useful tool. And so there's a couple of different version control systems. There's Git, which is what GitHub, GitLab, and Visual Studio uses. Then there's things like SVN, which is Subversion. There is Mercurial, I think that's what it's called. ClearCase. There's hundreds of them. Git seems to be the most popular, between Git and SVN, probably the most popular ones. And a lot of Git ones are free. I said GitHub if you're doing a public project, or Azure DevOps if you're doing a private project, or even a public one as well. I personally quite like Visual Studio or DevOps, and it gives you a lot of integration as well into Visual Studio. There is a lot of plugins for integration to GitHub as well, but I don't know them very well. So you can do all kinds of funky stuff, like create builds through it, and that's stuff I'm currently setting up at work. Pull requests, they're your code reviews, and you can see the history, or any stuff that you've changed at the moment. So if I go and change this and go as diff, you'll see down the bottom right here, it says one change. Oh, I'm actually on top of it, so you can't. But we can go over here and go changes, and it says there's one file changed, and we can see what we've changed. We've added a comment. Green is add, red is subtract, left is fuck off, left is old, right is new. And you can just do really cool stuff. If you're doing any kind of coding, no matter if it's more than just like practice, if you're doing an actual project, from the beginning, use a code repository, use source control. Get a free one online, make your own private one. It's very easy to do. You can set up a Git server, an SVN server in seconds. It's usually just an install. It can even be running on the same machine. I used to run mine in Dropbox. So you have it in the Dropbox, and when it uploads, when it checks in a new change, it uploads it to Dropbox, and you got a backup. Then I moved over to my own server. There's so much you can do if you're doing any kind of project for coding. It doesn't matter how big or small. Just set it up. It takes 10 seconds. Just do it. Whew. That's it. I don't actually know how long that went for, because I have to edit out like half an hour of stuff. So I assume about half an hour, 45 minutes. I really hope I got through everything, and when we get to Battleship, everything is understood. But that will be next, hopefully next week. But you know what I'm like with my schedule. It's all over the fucking place. Yeah, this is going to be fun. I fucking love Battleship. It's the first game I made, and I hope I've given you the instructions to make your own. And that's it. To quote Lewis Rossman, I hope you learned something.